3.5. Today we're going to perform operations with matrices. A matrix is just a way of organizing data into a table. A matrix has rows and it has columns. In this case, because there are 2 rows and 3 columns, we call this a 2 by 3 matrix. Towards the end of this lesson, we're going to see an application of matrices. But before that, we're going to learn how to add and subtract them and multiply them all by a constant that's called a scalar. We'll start off with some addition and subtraction. Adding matrices is as easy as you want it to be. When we've got 2 matrices, we just match the 2 numbers and add them together. You can only add and subtract matrices if both matrices have the same dimensions. In our example here, you can see we're adding a 2 by 2 matrix with a 2 by 2, and our answer is a 2 by 2. We can't add a 2 by 2 matrix with a 2 by 4 because the numbers won't match up. So let's take a look at some simple examples. Be happy that we're not multiplying matrices together right now. That's a lot more involved. You don't have to worry about that until at least the next lesson. So you can see when you add these together, you get the numbers that you expect to get. Nothing major going on here. If this seems like it's really easy, that's because it is. Of course, I messed up. -5 and 2 is not 3. It's -3. But this is really just adding up numbers. No tricks going on here. Subtracting is a little more complicated just because it's subtracting. Still works exactly the way you want it to work. Check to see that you got all the same numbers that I got. And that's really all that there is for adding and subtracting matrices. We can also multiply a matrix by a number on the outside. You see on part A we're multiplying by -2. On part B we're multiplying by 4. But on part B we're only multiplying the first matrix by 4 and then adding it to a second matrix. That number on the outside is called a scalar, and you can always multiply a matrix by a scalar and you get a new matrix. So I suggest you try these on your own and just check your answers with mine. Notice on part B I showed that extra step because I had to multiply through by 4 first, and then I added the 2 matrices together. At this point you can go ahead and pause the video or you can continue on. This slide just kind of tells you that the properties that are true for adding real numbers are also true for adding matrices. Associative property works, commutative property works, and distributing a scalar works just like you'd expect it to. Addition and subtraction are very friendly with matrices. So let's take a look at a real-life example. Go ahead and read over this problem and try to think of ways you could set up matrices to organize this data. So as you can see in the problem, we're supposed to organize data using 2 matrices, one for last month and one for this month. Both months we sold walnut, pine, and cherry racks. We sold small and large racks. So one way we might set up a matrix for last month is we could organize our walnut, pine, and cherry racks and organize them also by large and small. We could do the same thing for this month. We also sold walnut, pine, and cherry racks. We sold large and small. I'd recommend you pause the video now and try to fill in these charts on your own. Make sure you get the same numbers as me. Once we've got this data organized, we can now figure out the total number of each type of rack that we sold. And we would do that by adding the matrices together. We'll still get walnut, pine, and cherry. We'll still sell small and large. And we just add these numbers up. Try it on your own, see if you get the same numbers as me. Once you have that matrix, we're not quite done. This matrix organizes our data great. It tells us the total amount of racks that we sold of every type and size. But we want the average for the monthly sales. Since there's 2 months, we have to take this total amount and divide by 2. Another way of dividing by 2 is multiplying by 1/2. So once we do that, we'll have the average number of each type and each size sold. So see if you come up with the same numbers I do. Once we've got that matrix filled out, we're done. We can use this table to figure out any piece of information we want, such as the average number of large pine racks sold is 233. Our last example is solving for some variables in a matrix. This works out just like you'd want. I see this 3 is distributed into 2 matrices, so the first thing I can do is multiply everything in those 2 matrices by 3. Once we've gotten that taken care of, we can now add the 2 matrices together and come up with one matrix on the left and one matrix on the right. Once I've done this, you might notice that the pieces that don't have variables in them match up. If they didn't, that would be a good sign that I did something wrong. 15s match up, 3s match up. I also know, because these matrices are equal, that the x's have to match up and the y's have to match up. So you just got a little bit of simple algebra to do to solve for x and y. For instance, I could say 15x plus 9 must equal negative 21, and negative 3y minus 12 must equal negative 24. Go through the algebra steps and you'll get your 2 solutions. Once you've done that, you've done everything the problem asks for, and you're done. At this point, you can try this on your own, or you can do this one later. Other than that, we're done with this lesson.